I'll also start. Right, so let's see. Let me open this file. This is O levels. Dynamics. Okay, so yeah, here we have this thing. Okay, can you, so you're saying, how do I have this thing that, for example, FR, which is the resultant force, can be written as F1 squared plus F2 squared, right? The square of FR. One of the expressions is this one, and this is to find the magnitude of the resultant force. And then the other expression is to find theta, which is the tangent inverse of Fy over Fx, right? So these are, once you have these two things, then you have all the information about the resultant vector is known completely, right? The vector is known. This thing was just the magnitude, and this thing is a direction. Both of them combined forms a resultant force vector, right? So your question is, how do I have these two things? That's what you're asking?
Yeah, exactly.
Okay, all right. Okay, so, well, we'll have to consider this triangle again, where, for example, suppose this is F1, right? This is F1, and you apply some F2 in this direction, right? Now, how do we add these vectors? If you remember, we'll put head to tail these vectors. So I can put this F2 vector on the head of this thing, and this gives me the resultant vector, which would be like this. All right, so that's clear. This thing is
That's
clear,
true.
right? How do I add two vectors? Okay, so for the sake of simplicity, really, I'll just draw another diagram where, suppose this is F1 and this is F2. Now you tell me, what do you think, where would be the resultant force vector? It would be in between these two, right? So it would be something like, right? Okay, so now suppose that I take this F2, and because of parallel transport, I can take this vector and transport it over here, right? So if I drew this accurately, right, if I drew all of these vectors accurately, then this would form a triangle like this, where I have, this is the resultant vector, this is my F1, right? And this is my F2.
Oh.
So yeah, now it's just a matter of using the Pythagorean theorem, which just says that Fr squared, which is the hypotenuse, is just F1 squared plus F2 squared, right? And that gives you your resultant force vector. So is it, yeah, okay, good. Now let's talk about this thing. So this one is clear, right? And this one is what we are going to talk about. Okay, so now let's look at this resultant vector. So it's this vector, right? So I'm just going to take this resultant, copy, and just paste it over here. All right, now this is FR. If I consider a coordinate system where this is a vertical line and this is the horizontal line, this is my x-axis and this is my y-axis. This is a choice of coordinate system, right? Now, if the coordinate system is such that these two are orthogonal, or you can use the word perpendicular to each other, that just means that there is no part of x in y and there is no part of y in x. Now I can divide this FR into those two parts, really. So I can break this and I can say that if this part is FRY, this, now I'll just ignore this R, right? For the sake of simplicity, it's understood that that's the resultant force. And then this thing is Fx, right? Because this component of this force is along x-axis and this one is entirely along y-axis. So again, if you think about it, if I were to add fx and fy, the resultant would be this thing. So now, first we did this thing where we took the two different components and we added them together to form a resultant component. Now I'm breaking down the resultant component into its components and saying that this is fx and this is fy. All right. So if that's clear, then again, I can just take this thing and move it over here, right? This forms a right angle triangle. And let me clear things up. So this is f, that's fy. And this is the angle with the horizontal axis. Now I need, what do I need? I need theta. I can write theta because I know that tangent theta is, from mathematics, we know it's opposite side divided by adjacent side, right? And in this case, what is opposite? Opposite is the side which is really opposite to this angle theta, which is fy, right? And what is the adjacent? It is this one. If this is 90 degrees, then this is the adjacent or the base, right? And that's fx. Now this gives me tangent theta is equal to fy over fx, and then theta is just the tangent inverse of that thing, fy over fx. So that's how we get these two expressions. That's one of the ways that you can, derive these two relations. So does that things clear? All right. Okay, good. So, okay, so that was your question. How many people do we have right now? Okay, so we have a couple of people in here. Is there any other question from anyone regarding the last lecture? Any questions? Okay, I think there are no questions. If you have any questions, feel free to stop me and ask your questions. So that's really what we ended at during the last class, and we found that so from this thing, we are talking about these things, right? What would be fx explicitly in terms of fr? So that would be fr cos theta. And if as I asked that if anyone has any questions, then no one had a question. So now, can you tell me what would fy be in terms of the resultant force and the angle theta? Using the methods of mathematics, the methods of triangles and trigonometry, right? That's a hint. And now, can anyone tell me what would be fy? Any guesses? Okay, I guess I'll just repeat this thing, how I found fx, right? We did the same thing. We drew this triangle where this is this was fy, this is fx, right? The same thing that I just did on the next page, and this was my fr, right? Now, if this is my angle theta with the horizontal line, which is theta, then I have these three expressions from mathematics. If I want to write fy in terms of fr and theta, and have fx should not be there. So which of these expressions can I use? I can use sine, right? Because sine is, we have opposite, and in this case, the opposite is fy. We have hypotenuse, which is fr, and then we have theta as well, sine theta. So this gives me sine theta is equal to fy divided by the hypotenuse, which is fr, and then rearrange this, bring this fr over here. So this becomes fy is equal to fr sine theta, right? So fy component would be fr sine theta. Does that make sense now?
So I have a question.
Yes.
So will we be able to use tan theta to find fy?
Okay, so suppose that you use tan theta, right? So let's do an experiment. Let's see what happens, right? Suppose I take tan theta then tan theta is opposite over adjacent, right? So the opposite side is Fy, but adjacent side is Fx. Now, this thing can help you find the angle theta, but you know, you cannot really do anything else with this expression, because whenever I have to divide a vector into its components, so for example, this is my vector f, I have to divide it in components, this one and this one. This is fx and this is fy. So these two components are unknown. So I cannot use this expression to find any one of the components because both of them are unknown. Of course, if you know fx, then you can use this expression to find fy, right? If you know fx. So I mean, I enjoy doing this, and I'd recommend all of you to do this as well. When you have equations, play around with those equations, obviously following the rules of mathematics. Play around with those equations, and you know, you might find some interesting things when you do so. And that's one of the reasons why I said I asked you all yesterday to find what would fy be, and you know, that would have led you to play around with these sets of equations, and you know, you can always find interesting stuff from that. So yeah, any other questions? No questions? No more questions from the last topic that we did?
No, sir.
No questions. Okay, so is this all of this thing is clear for everyone? So I'll just quickly write some of these points that you should know from all of this discussion so far. Is how can you find fx and fy given fr? Similarly, how can I find the angle theta now given fx and fy? And another thing is, how can I find fr given any f1 or f2? These 1 and 2 are arbitrary, they can be anything, right? So fx, fy, f1, f2, right? So for this thing, it's very simple. We know fx is fr cos theta, and fy is fr sine theta, right? So I'm just summarizing all these main expressions that we talked about. To find theta given fx and fy, it's simply theta is tangent inverse of fy over fx. So we have looked at these expressions, where do they come from and everything, right? And this one, fr, from this, it's very simple. Fr squared is f1 squared plus f2 squared, comes from Pythagorean theorem. So these are some of the expressions that you should know after all of the discussion that we had so far. So these three expressions, are they clear?
Yes, sir.
Okay. For
Yeah,
everyone?
clear.
Clear for everyone?
Clear.
Okay, good. Amazing. All right, great. Okay, so if that is the case, then we'll quickly talk something about something that's way simpler than this thing, right? So suppose that you now, we talked about the hard stuff early on. Now let's talk about the easy things. So suppose you want to add parallel vectors. So if the vectors are parallel already, right? So what do I mean by that? I'll tell you. Adding parallel vectors is so simple. Suppose that I have two vectors. Let's consider an example of a block. And suppose I apply a force on this block, F1, and another person comes along and he applies another force, F2. So person 1 applies this force and the person 2 pushes the block with some other force, F2. Both are pushing this block from the same side. Whatever the resultant force this block would experience is some FR. Now note that all these vectors are parallel to each other. Now, if these vectors are parallel to each other, they don't make any funny angles with each other, right? So they are always in line, you can say, with each other. Which means then now I can add these vectors f1 and f2 as fr is just f1 plus f2. Why, if the vectors are parallel? How is this different from the case that we were talking about previously? Remember previously the vectors were like this. So one vector was like this, one vector was like this, or it was like this, and one was like this. So this was f1, f2, and here's this is f1, f2. So these are not parallel to each other. If they're not parallel to each other, then you need to do some funny mathematics and figure out what would be the resultant vector. But if the vectors are parallel, as you can see over here, then it's very easy to add vectors. You just take them and add them, right? Just, you don't have to do all that squaring and all of that things, right? So I can then generalize this expression. Suppose you have n number of forces and all of those forces are pointing in the same direction, then this expression can be generalized as Fr is just the sum of all the forces that are acting on a body, right? So is this point so far clear? Adding
Yes,
parallel
sir.
Yes,
vectors.
sir.
Okay, good. So this was pretty simple. And now let's just suppose that I have a block and a person one applies some force from this side, and the other person, he does not want this person one to win for whatever reason. He applies some force from the opposite side and he's like, no, just let the block stay where it is, or let me move it towards you. He applies some force F2. So now the block is confused. It doesn't know where to move. So the block has to do some mathematics to understand where should I move? Should I move to the right or should I move to the left? So the block does some mathematics, and the mathematics that it will do is, first it will have to define a coordinate system for itself, where we can say that the force to the right means positive signature and the force to the left means negative signature. Then the resultant force would be, because F1 is to the right, so I'd put plus F1, and F2 is to the left, so I'll put minus F2. So that's the resultant force that the block will experience. Is this point clear?
Yes, sir.
So I have a question.
Can you, sorry, can you repeat?
Yes, sir, I have a question. So
Yeah.
if we already know that F2 is to the left, then
Yeah.
why do we have to subtract it, sir? Like it will always be negative, right?
No, you're saying why, if we already know F2 is to the left, then why do we have to subtract it from F1?
Yes. If we have already defined that F2 is negative, then why do we have to subtract it? Wouldn't we just have to
Oh,
add it?
you're absolutely right. If I got you what you're saying, it's kind of pointless to think in terms of addition or subtraction. The neater word is sum, and sum does not mean plus. Sum just means that you combine the vectors together. So what I'm saying is that the FR would be the sum of all the forces. Now F1 is to the right, so that's plus F1. I'm just combining these forces. Now to combine F2 with F1, because F2 is to the left and I say that means it's negative, then I have to write a negative F2, because F2 carries a signature with it, which is minus. Is that what you were asking?
Yes, sir. So we already know that So to define that F2 is negative, we have to put a subtraction sign, so just
Oh
go ahead.
yeah. So I think your confusion is F2, saying F2 is negative is also kind of confusing. F2 carries a negative signature with it, is more sensible, right? Because I think maybe you're thinking that F2 is negative, meaning whatever the value in F2 is, for example, 2, that would be negative. So what's the point of adding this negative? That's not true. So F2
Yes, sir.
carries with it, yeah, whatever value F2 carries, it carries along with it a negative sign. So for example, F2 was 10 newtons. Then because it's to the left, it carries a negative sign with it. So it's not, F2 is not 10, but it carries along with it a negative sign like this, right? So that's minus 10
Okay, sir.
newton, right?
Okay, sir. Got it.
So hopefully that makes things clear. All right. Okay, so everyone is following along up until this point? Is it clear?
Yeah. Yep, sir. Sorry.
Okay, great.
Must like.
All right, so now we can talk in terms of motion as well, right? How does a force give rise to motion? That's how we started off our discussion with, right? Because in kinematics, we ignored force altogether. In dynamics, we want to understand how would this force give rise to motion. The first thing then obviously was to understand force. And by this point, it should be clear in everyone's head what is a force and how can we play around with forces, right? Meaning how can we do, how can I do the, how do I do algebra with forces really, right? Adding, subtracting, and so on, right? So this thing should be clear in everyone's head by this point. So is it like that? Is everyone clear with the concept of force and its mathematics?
Clear, sir.
Okay, great.
Yes, sir.
So now we'll move on to forces, force and motion. How does force give rise to motion, right? Or how does it change the state of a body or change the state of motion? Okay, so let's quickly talk about some of the things that a force can do, right? So let's ask a question: what can a force do? So I want all of you to give me your, ideas. Anyone, what can a force do
Mm,
to a body, for example?
Push.
Yeah. So okay.
so
So one is
it can
something.
cause
Pull.
Yeah.
it can cause
Yeah. Go on.
matter. So it can cause acceleration to a matter, to
Cause
some
the
mass.
acceleration. Yeah. Cause acceleration to some mass. Okay. Any other ideas?
It pulls of the object.
Yeah. So we'll pull.
It can stop motion.
Okay, that's a good one. It can stop motion altogether. Anything else? Anyone
It
has
can
any more
attract an
ideas?
object.
Yeah, so attraction, which is kind of really pulls, right? So yeah, attraction. But that's another way to think about it. Yeah. Okay.
Yeah.
So yeah, so these are some of the things that a force can do. I'll now so this is all of this came from all of you, right? And it was amazing. All these things are exactly what a force can do. But I'll just generalize all these ideas into 4 different statements, right? So the 4 different statements I'll say is that, for example, suppose a body is at rest or it is not moving. So a force is going to cause that body to move. So it will, you can say, in terms of a body, it causes a body to move from rest. Okay, so that's one thing. And there are a lot of points that are being covered in this thing. So push and pull, for example, something that was not moving, you push it, it will move. If you pull it, it will move, right? So all of that is coming under this statement. Then we have that, for example, a body is already moving. So what will a force do to that body? It can either increase the speed of that body or it can decrease the speed of that body, right? So suppose if something is moving to the right and I push it, so I'll increase the speed. But if it's moving to the right and I pull it back towards me, then I'll decrease the speed of this body, right? So a body's speed may increase or decrease, right? And what's next? So I said 4 points. I just took 2 points and I wrote them as 1 point, saying that a body speed may increase and a body speed may decrease. So in total now we'll just have 3. And the last one is, so what could be the last one? Think about these 2 points. These are, I'll give you a very big hint. These are in terms of the strength of any quantity, right? So velocity, speed, right? It's the strength of the speed, or really magnitude. Think in terms of direction. What could a force do in terms of direction? Because remember, force
it
is
can
a
change
vector,
its
right?
velocity. It can change its velocity.
Yeah. So in terms of direction, what would that mean? It would change the
It
body's
can cause it to accelerate
direction.
or decelerate.
Yeah. In terms of direction, it would mean that it would produce a change in direction, right? So a very simple example is a book on a table. For example, if someone applies a force over here, then this book moves over here. And if someone immediately comes along and he applies a force like this, then the book would change its direction and it would start moving. Is somewhere in between these 2 lines, right? So it would. So a force can produce, or you can say it can cause a change in direction. Now, having these 3 points, we have more or less covered what a force, is capable of. What can a force do? So if a force acts on any body, these are the 3 things that can possibly happen because of the force. So is there any question regarding this?
No, sir. Everything's good.
All right. Okay, so that's good. Okay, so now let's talk about Newton's laws of motion, right? Before I do that, let me think. No, I think let's talk about Newton's laws of motion. And the reason we'll start talking about Newton's laws of motion is because we want to see how would a force affect motion. And Newton wrote down some laws to tell us how would a force have an effect on motion. So let me give it a heading: Newton's laws of motion. All right. Okay. So we'll start with obviously the first law. And of course, now I'll dictate these laws in a more, in a different way than Newton wrote them down, right? So because Newton wrote them down, it would take you some time to understand what Newton really meant, and now we understand what that meant. We'll write them in an understanding that would be more clearer. So the first law really states that a body will remain at rest, or it would be keep moving. It would keep moving with a constant velocity unless unless some net force acts on it, or you can say unless a resultant force acts on it. So again, the statement says that a body will remain at rest or it will move with a constant velocity, meaning that the velocity will not change unless a resultant force acts on it. So as soon as a net force acts on the system, then its state of motion will change. And in modern terms, this law is also something that defines an inertial frame. An inertial frame is a frame where there is no acceleration in that frame, right? So what I mean by this is, for example, let's break this law down into two parts, really. So you see that a body will remain at rest or move at constant velocity. That is straightforward, right? Because of course you do not expect any object to move all of a sudden, right? So something, for example, you would not expect you have your phone lying on a table. You're not expected to move all of a sudden, unless of course you believe that there are ghosts around you, and then you'd be like, you make up a lot of stories and so on. But of course, let's ignore that, and you would not expect anything to start moving on its own, right? Everyone agrees with that?
Yes, sir.
Okay, so
Yes.
then the first part of this is, everyone agrees with the first part, that a body will remain at rest or it will move at any constant velocity, right? So if it's doing something, it will keep doing that. If it's stationary, then it will remain stationary. The second part is where you have that unless a resultant force acts on it. So think about it like this. Suppose that, okay, how do I say this? For example, let me give you an example of a golf ball, right? And if I put this golf ball along a level ground, right? The ground is level, and suppose I hit it with the golf stick. I'm not going to draw the golf stick. After, it will keep moving and moving, and after some time, it will slow down, right? But according to the first part of this law, you would not expect the ball to slow down. You'd be like, if it was moving at some speed, then it should have remained. It should have kept moving at that speed. So why does this ball slow down? Does anyone have any idea? Any
So
thoughts?
it's because of friction and air resistance.
Good. Okay. Yeah. Okay. So yes, more or less that's the right answer, right? Because friction is there because the ball is in contact with this ground, and of course, the friction from the ground would be opposing this direction of motion. As we discussed, that's what friction does. And then, of course, there will also be some air resistance because the ball is not in vacuum. There are air molecules, and because it would have to fight against these molecules and push them out of the way, so the ball will slow down. But well, friction, we know it's a force. Air resistance is also a form of force. Now, because, for example, the force that caused this ball to move forward was some F, these two forces together, air resistance, I'll just call it A, and friction F. So suppose that I'm saying air resistance will also act in this direction. So if left is minus, then I'll add a minus sign with these two. This is air resistance, this is friction, and this is plus F. F is the force that which you hit the golf ball with the stick, and the golf ball started moving forward, right? Now the resultant of this thing, if it's less than F, then you would expect the ball to slow down, right? Because the if it's more than F, my mistake, right? I should really say something like this. If these forces are greater than F, then the ball would start slowing down. Does everybody agree with that?
Yes,
Or
sir.
do you have any question? Okay, so now if these forces together are equal to F, then nothing